This is video 6.2.4 for algebra. The goal here is to learn how to use elimination more often. So many of you like elimination, so we're going to take a look at how you can use it more often because you become so good at it and you like it. It's fast. So how can we use elimination more often? Well, you can use elimination as long as these requirements are met. The first requirement is that you line up the equal signs. Here's what I mean by that. We're going to do that for the first two examples. We're going to line up the equal signs. The first example, the equal signs are already lined up. See how I can draw a line through them? So I have to make sure that when I do elimination, the equal signs are right on top of each other. In example 2, you'll notice that they are not. So what I'm going to do, and I'll rewind a little so you can see that, if you saw the equal signs, they are not lined up. They are offline. Okay, we want to put them in the same line. So I'm going to rewrite the first equation so that the equal sign is underneath the other equal sign. I'm going to line up the equal signs. Now the equal signs are lined up. Okay, so I'm going to line up the equal signs. It's always my first step. And we'll show you that they are in a nice line now. Now, my second thing that I need to do in order to use elimination, after I've lined up the equal signs, the second thing you need in order to use elimination is a variable must eliminate. So if I'm going to use elimination, I have to eliminate a variable. So let's take a look at example 1. Example 1, when I add the two sides of the equation, the nothing eliminates. Here's what I get. I get 12x's on the left and 16 minus 10y on the right. Do not write this down because it doesn't actually help me solve the problem. So in order to do elimination, I need something to eliminate. And this is where we use that idea of multiplying the equation by something so something will eliminate. So what I'm going to do is I'm going to create a negative 8x in the first equation by simply multiplying by negative 2. Then something will eliminate. Again, I'm going to keep my equal signs lined up. So I'm going to write equals, and of course I'm multiplying the next term by negative 2 times 7, and I get negative 14. Continuing this, I times negative 2 by negative 5 to get the positive 10y. So I simply times everything by negative 2, and I know you've seen this in your classes. Now something eliminates, so the first two requirements are met. I've lined up the equal signs, and now something will eliminate. Because when I add these two equations together, I get 0 x's on the left, so I get 0 on the left-hand side of the equal sign. On the right, when I add things up, 9 and negative 14 make negative 5. Adding the other like terms, the y's, it's minus 5y plus 10y makes positive 5y. Now I have an equation with one variable, y, a variable eliminated. So now I can solve this very easily. So I'm simply going to add 5 to both sides so the y's are alone, and I get 5 equals 5y. And my last step is I want 1y, so I'm going to divide both sides by 5 so that the 5 turns into 1y, and I get an answer of 1 equals y. Now of course I'm only halfway done with my answer. My answer should have x and y. So remember, your final step is always to plug it in. So I'm going to go back to one of the equations, and I'm going to put 1 equals y in for y. So where y is, I'm going to put 1. So everything else copies. 4x equals 7 minus 5 times 1. Now I'm going to solve this equation. So let's see, 7 minus 5 times 1. Following order of operations, I do 5 times 1, I get 5. 7 minus 5 is 2. So I get 2 on the right-hand side. I have one more step to solve for x. I divide both sides by 4. When I divide 2 by 4, I get 0.5, or 1/2. So x is 1/2. So my correct solution in ordered pair form is 0.5, comma 1. 1/2, comma 1. That is the solution to this system. Now I look at example 2. In example 2, I've already lined up the equal signs, but I need to check for requirement number 2, that a variable eliminates. Again, if I add everything on the left, I will get 2 x's and a y. So the x's will still be there, and the y's will still be there. So I don't even need to look to the right-hand side to see that this is not going to eliminate. So before I start this problem, I'm simply going to solve and change the top equation by timesing it by negative 1. Because then I have an x and I have a negative x, and they will eliminate. Now I add that red and green equation and see that the x's will eliminate because negative x and x make a 0. So I just have negative y. On the right, I still have the 2y's, but I can put the minus 3 and the minus 12 together, and they make a total of minus 15. So I eliminated the x's, and I have only y's left over. That's good. Now I can solve for y. So now I'm going to get y alone. Let's see, the y's are alone on the left, so I'm going to move the 2y's over as well by subtracting 2y's from both sides. That eliminates the y's on the right. On the left now I have negative 3y's, and on the right I still have the negative 15. One more step. I divide both sides by negative 3 to find out what 1y equals, and I see the solution is y equals 5. But don't forget, you're not done with the problem yet. You have to find x as well. So now we go back and plug it in and find x. So I'm going back to my original equations, always go back to the original, and we're going to put 5 in for y. I'm just taking the first equation. X equals 2y minus 3. Now I'm going to plug in 5 for y. 2 times 5 minus 3. 2 times 5 is 10, minus 3 is 7. So that means my x value is 7. So my solution to this ordered pair is 7, 5. Now don't forget you can check your answer, and it's a simple check by using the other equation. So we use this top equation first to find 7. Now we use the bottom equation to check our work. We plug in both 5 and 7. 7 for x, 5 for y. And we check 7 plus 5 because it was x plus y. And we see that 7 plus 5 does in fact give me 12, like it's supposed to. It's supposed to give me 12. So I know my answer is correct. We can do that in the other equation as well, on the other example, excuse me. So I can go to this equation. Remember, we did not use that equation to find our y, or x, excuse me. So if I plug in x and y, I should get an equation that's true. So the equation is 8x equals 9 minus 5y. So I'm going to plug in both x and y. So I'm plugging in 0.5 for x, and I'm plugging in 1 for y. 9 minus 5 times 1. And I'm going to see if the solution is if these two sides are equal. 8 times 1/2 on the left-hand side gives me 4. So the right-hand side should give me 4 as well. And if I check, this right here is just 5. 5 times 1 is 5. So I end up getting 9 minus 5, which is in fact 4. So my answer checks out because it creates an equal statement in the other equation. So the beauty of systems is you can check your work. And I bet if you were on a test and you checked your work, you might be able to find any mistakes you made if you find out you made a mistake and you got the wrong answer. So check your work. If you get something that is not true, if these two sides were not equal to 4, like they are here, if they weren't both 4, then I know I made a mistake. So check that work. It's worth it on a test. Do that extra step. So today you're going to see in your problems, you're going to see some problems that are different, and sometimes we use things like substitution to solve them. But try elimination by following these two requirements, that you line up the equal signs and that a variable eliminates, and you will be able to use elimination. So good luck, ask your teacher lots of questions, and remember to check your work.